This is section 3.3, part 2 of chapter 3. 3.3 is derivatives of trigonometric functions. So I'm going to go ahead and star these. These are something that you do need to know. You should have these memorized. Going through some proofs. This first one that we have here is, starting this off, we're going to be using find the derivative of cosine of x. The derivative of cosine of x is going to be equal to the limit as h approaches 0 of cosine of x plus h minus cosine of x divided by h. Using the sum of angles rule from pre-cal or from a trig class, we can rewrite this. Rewording this a little bit and rewriting a little bit different, we have down here. See if you can figure out how that was done with removing around some terms. Then taking the limit of each of these values individually, you will notice that this right here is an issue, as well as this. Well, this one will just equal 1. We've actually done something just like this previously, and this is by the squeeze theorem. And the limit h approaches 0 of cosine of h minus 1 all over h equals 0. And you could look in the textbook on page 192 in the book for a little bit of help there. So see if you guys can find and do a proof of tangent of x is equal to secant squared of x. I'll leave that for you guys to try. Down here we're going to just go ahead and do some examples. First of all, the definition of differentiate is just an act of taking a derivative. So we have y equals, remember to start this off you need to put either y prime or dy dx, something to tell us that we're actually taking a derivative. If you do not put this, it is technically wrong. And we have 2 times the derivative of cosine of x, which is negative sine of x, plus, now if you notice we have 2 things in here, so we are going to have to be using the product rule. So the first thing that we have is 6e to the x times the derivative of secant of x, if you look up above, is secant of x, tangent of x, plus the second thing that we have, secant of x, times the derivative of 6e to the x, which is just 6e to the x. This is not okay to leave our answers in this form. We need to simplify it. So go ahead and put an equal sign and see if you can clean it up and get it to match the answer that's posted on Canvas in the notes. Let's go ahead and look at the next example that we have down here. This time we're going to find f prime of y. Notice that this time we are dealing with a quotient, so we will have to use the quotient rule. Quotient rule starts off with the denominator, a low d high, or the derivative of the top. The derivative of sine is cosine, minus the top, which is sine of y, times the derivative of the bottom, which is 6y, minus, and the derivative of tangent y is secant squared y, all divided by the denominator squared. Again, this is not okay to leave our answers like this. The textbook doesn't. We will not. Even my Open Maths does not leave their answers this way. So you need to be able to simplify them. So go ahead and put an equal sign. And then again, I want you guys to see if you can clean it up, make it look a lot nicer, and then check your answer to what we have posted on Canvas. Okay, this continues on to the next page. We'll do a few more together. Okay, so the first one on here, I'm going to go ahead and circle. This is one I want you guys to give a try, and if you have questions, please let me know. It is worked out completely on Canvas, and I think that you guys should be able to do that on your own. And again, if not, let me know. The next problem says find the second derivative of this function. And we have y equals x squared cosine of x. So we're going to first find the first derivative, y prime, or dy dx, and this is going to be the first term. We have 2 terms here, so the first term times the derivative of cosine, which is negative sine x, plus the second one, which is cosine of x times the derivative of the first, which is 2x. Cleaning this up a little bit, we have negative x squared sine x plus 2x cosine of x. So from here, we're going to have to find the second derivative. So if you notice, we have two different terms here. Both of them have two things that both have the variable x being multiplied together, so we have to use the product rule. So looking at the first term here, I have negative x squared sine x. So we have negative x squared times the derivative of sine x, which is cosine of x, plus the second thing, which is sine of x, times the derivative of our first term, which is going to be negative 2x, plus, I'm going to take the derivative of the second term that we have here. So our first item is 2x multiplied by cosine of x. So we have plus 2x times the derivative of cosine of x, which is going to be negative sine of x, plus cosine of x, times the derivative of 2x, which is just times 2. Again, we will not leave our answers not cleaned up and looking a lot more nice. So see if you can simplify this a little bit, clean it up, and again, check your answer online. Okay, the next one that we have down here is finding the equation of a tangent line to the curve y equals 2x sine x. So again, product rule at this given point here. So in order to find the slope of the tangent line, I need to take the derivative of this. So dy dx, or y prime. And again, we're using the product rule, so it's the first, which is 2x, times the derivative of sine, which is cosine of x, plus the second, which is sine of x, times the derivative of the first, which is 2. And since we're dealing with this at the point pi over 2 comma pi, I need to evaluate this at x equals pi over 2. And if you go ahead and plug in pi over 2 and evaluate cosine of pi over 2 and sine of pi over 2, you should have this working out to be 2. So maybe show that work and see if you can understand that. Maybe use your unit circle if you need it. From here, this tells me my slope of the tangent line. So y minus y2, or y1, I'm sorry, equals m, which we have as 2, times x minus pi over 2. And then going ahead and again cleaning this up, it does not say which form this has to be in, but a lot of times they want them in slope-intercept form. And rewriting it in slope-intercept form, we get y equals 2x.